Okay, yeah, thanks for having me. My name is Christoph Hennig from Luxoft. I'm responsible for the virtual validation area. We call it digital twin at Luxoft. And yeah, we are really coming a bit from the embedded software development background, especially looking at SDKs and middleware to execute tests on the target platform. So something like integration tests and AUSTOSAR. And I want to talk a bit about how to enable this and some initial points to consider for SOAFEE. So I want to give a short overview of virtual validation. What is the impact in SDV? What's the concept behind this vECU? Yeah, this is one of the, I think, key aspects and the benefits that could be brought by SOAFEE. And also, let's look a bit at this process that you have to have in mind to include this. And we have one, use case prepared that is showing this co-deployment on, for example, the hardware target on ARM. So to introduce this a bit, I can just maybe share what we are seeing at the moment and what we are doing in this area. So we are already using virtual validation in a productive environment. Yeah, so really reducing actual hardware tests with virtual tests. And the goal is, of course, to decouple this. So hardware and software, you get faster feedback for the developers, especially by considering the automation. And you can co-deploy this then depending on the test case that you have. So accessibility and scalability are, of course, some of the main benefits that are required for this. Yeah. And on the big picture for AD, yeah, this is just trying to summarize this a bit. You are trying to have an intermediate step using virtual validation from your code development, so AI-based or normal code development. And this requires in the center a kind of a platform that exists, that consists of the simulation tools, the environment, that also utilizes the data. And on the right side, you can basically see that with this, considering the V model or ASPICE levels, you are introducing a kind of a virtual target into your development process. And from this, I think it's clear on a system level that we have to derive multiple areas to focus on. So something like, how do we build this target? How do we set up the environment? And how do we build a process that is still usable by the developer? Yeah, so I think these are three of the core challenges to consider when we are introducing this to the system. And yeah, as a background here, so this virtual ECU, I know we are talking in SOAFEE about containers and that are placed in the car and so on and in the backend. But from the nature, basically, this virtual ECU is something that should replicate the behavior of the real ECU. It's a concept that can be discussed if we can also change the architecture of the in-vehicle part with SOAFEE, but in general, you want to basically have the capability to develop things in parallel using this virtual target and the actual target. So depending on the test maturity, you have maybe unmodified software or you're looking at isolated integration levels. And in the SOAFEE architecture, you can see that this is really the part where we have to think about setting up this environment for such a virtual ECU. Yeah, so this is more kind of a background also maybe to read up on. And I mentioned this development process. This is one, I think, of the main challenges as well, because this could be a very complex toolchain to use for the developers. So I just show here a reference architecture, which could be considered. Yeah, so the heart of this will be a test framework that is triggering the tests and utilizing resources. But at the end, we should define together how this cloud instance and this virtual ECU environment is set up. So are we considering automotive middleware like AUSTOSAR, or which kind of tests do we want to do? Are they more on the functional level, or do we want to go into the hardware level as well? So depending on the test case, this environment has to be configured. And the developer is, again, here the one who should not set up this fully. So automation and deployment in AWS, for example, would be the key aspects here. I want to highlight two use cases. I think in the session before, especially the first one was discussed. So you could use this virtual instance to complement development on hardware. So you are, instead of using the actual hardware, you are using it as if it would be the real hardware, so you can actually debug on it, utilize the hardware aspects. So this requires a full bring up and considering of memory aspects as shared before. But another use case would be the second one to consider this, that you are using this to complement and co-validate. So isolated components or maturity features can be tested on integration level. So this is something where you are building software releases and flashing this to the real target. And in this case, utilizing this cloud instance from SOAFEE to do that. So the test plan behind this is something that drives the configuration of the test system and the environment. Yeah. And I promised to show one of the use cases here, which I could see, yeah, especially with AUSTOSAR was also mentioned today. So if we want to introduce this test, coming back to this picture, then we could consider that actually, if we are able to do an integration test onto the AUSTOSAR interfaces, this would give us a benefit to avoid this large step moving from a software on a simulated simulation environment to the actual automotive environment. So this allows you to move this test coverage to an earlier stage and get feedback. Yeah? But this means that we have to consider building this AUSTOSAR middleware in this container environment, and we also have to have a capability to co-deploy this on different targets. And for this, we have kind of a concept which we are happy to share also with the group, right? So we are using an Luxoft SDK for this, but basically it's an AUSTOSAR demonstrator compliant SDK. You could use any SDK, but this one we can basically change as we want. Yeah, and this is something where you can then build your AUSTOSAR adaptive application for any kind of target. So it could be the SOAFEE container, could be a virtual machine, or the actual ARM target. And then you are basically co-deploying this to your targets. So this is something where a full workflow through LCD could be enabled here. And it would be, I think, a very interesting proof of concept to consider as one of the implementations for SOAFEE as a reference. So to utilize this, deploy one of the reference functions and deploy this on the container and run this in the environment. Yeah, so I think this could be, for us, would be one of the priority focus points to contribute. And so we hope that we can also show a bit more in this topic in the future. But this would really then allow you to decouple the actual implementation and then the validation to the different targets. So to summarize this a bit, what can we achieve with that? So I just have another case here. So from autonomous driving perspective, you can actually achieve to run on the right side different types of ECUs. So I mentioned some are low level on the hardware. You want to understand if you can flash to this target or not, or some are, more on the functional level. They do not require the automotive middleware, or you could build then constellations of ECU virtualizations to match kind of a HPC architecture. And the test cases that we have in mind would be for AD to go one step further from training of functions and simulation and pure ZIL to get earlier integration tests as a feedback for the developer. And this would, on a simplified picture, mean that you are actually increasing the test coverage by virtual targets on the lower SWE levels. Of course, this is fully depending on the test plan, because you need to decouple the architecture so you can actually isolate components to be tested on the targets. But at the end, you would then shift this load more to the left side. We are not seeing that you would maybe get completely rid of the hardware level, especially looking at the higher system levels. I think there is still a benefit to use a hill or something at the end for a larger system level test. But this approach gives you massive benefits in terms of accessibility to the developer, in terms of independence from the hardware. Yeah? So you could utilize a model of the hardware at a much earlier stage and start integrating on it with teams working in different domains. And as mentioned before, I think the key will be for SOAFEE to prove that you can actually run more complex integration tests on it. So using automotive middleware or utilizing capabilities for hardware aspects that should be covered. And this could be also a cool example to implement with AWS to spin up multiple containers in this setup and then prove this kind of concept. Yeah, and of course, these values here are just arbitrary, but in reality, behind this is kind of a larger test plan where you can select kind of which tests you want to execute on which target. So this is a bit the scope that we are looking for. And as mentioned, we are utilizing this approach already. And it would, of course, be a larger increase of benefit if we are doing this with the SOAFEE environment, considering the capabilities to execute more complex and hardware specific tests on it. Yes, so this is all from my side. I'm really happy if there would be some questions, of course, and otherwise feel free to reach out. Yeah, thanks a lot.
Thank you, Christoph. So this is really interesting because the virtual CPU, the running and in the cloud is really going to enable this shift left paradigm of bringing your development earlier into for the software-defined vehicle. So thank you for that. If you could